Alright, welcome to Lesson 2 of Unit 9. Similar polygons. So definition, two polygons are similar if their corresponding angles are congruent and corresponding side lengths are proportional. Now, similarity and congruence are different. Congruent polygons are going to be the exact same. Everything's going to be the same. Similar polygons can be congruent, or they can also be smaller or larger than each other. So there's a little bit of difference there. So a similarity statement, if we know that triangle ABC and triangle DEF are similar, we write it like this. This says that triangle ABC is similar to triangle DEF. This little squiggly line means similar. We also have this thing called the scale factor, just like we did with dilations. In fact, dilations are a form of similarity. If two polygons are similar, the ratio of corresponding side lengths is the scale factor K. So we have this scale factor that tells us what happened. So if we go from the triangle on the left to the triangle on the right, we see that the sides go from 5 to 10, 6 to 12, 7 to 14. So they're all doubling. So that's why our K equals 2, because our scale factor is times 2. Now what we're going to do is we're going to determine if these are similar, and then we're going to state the scale factor. To determine if they're similar, first thing you should look at is the angles. Are all the angles congruent? Well, it looks like we have all our corresponding angles congruent. They're all right angles. That's pretty easy. Now we look at the sides. We have two rectangles. So it means you only have to look at two sides that are different. So let's look at AD, AB, WZ, and WX. What you do is you compare them in a ratio, and you simplify the ratio as need be. So if we're going to look at AD over WZ, that's going to be 2 over 6, which simplifies to 1 over 3. Now we're going to look at AB over WX, and we get 3 over 9, which also simplifies to 1 over 3. And you need to remember, if the first ratio you do is small on the numerator and large in the denominator, that's the same way you have to do your other ratio, small and then large, in order for this to work. And we see that we get a 1/3 for each. So we can say yes, they are similar, and we can say that K equals 1 over 3. Or we could say that K equals 3. It'd be the same thing. It just depends on which way you go. So here are two examples of trying to prove that these two are similar, and I want you to use the same ideas as we just did. So go ahead and pause the video and work this through in your group. And here are the solutions to those two examples. As you can see that yes, they are both similar. The triangles are similar and their ratio is 1/3, or you could have got their ratio as 3. And the rectangles are also similar, and their scale factor is 2/3, or you could say the scale factor was 3 over 2. Next we're going to talk about finding the missing sides. And to do this, we're going to assume that both of these are similar. And I need to make a correction. Pretend you didn't see that. So, sorry. What we need to do is determine what the scale factor is, and then we need to use that scale factor in a proportion to find our missing side. So the triangles, it's a little bit difficult than it would be with a rectangle or with a square. Because with the triangle, we need to make sure that we match everything up. So we know that these two triangles here are similar. Now we just got to pick the correct ratios. So what I'm going to do is I'm going to kind of look at this and think that, well, maybe 14/35 is equal to 16/40. And to test it, I'm going to cross multiply. And if I get the same number, then I know that I'm right. And we get 560 equals 560, which, luckily, that was the correct way to go about that. So that means that this x length and 25 are going to be a ratio. So what I'm going to do now is I'm going to pick one ratio that we know. I'm going to set that equal to the ratio with x in a proportion so that we can find that missing side. So I'm just going to use the 14/35. I'm going to set that equal to x over 25. And remember to make sure that you keep triangles in the same place. If you're using one triangle in the numerator over here, you have to use everything from that same triangle in the numerator here. Same thing with denominator and denominator. So now we're just going to cross multiply, and we get 35x equals 350. Divide by 35 and we get x equals 10. Alright, so now what I want you to do is you apply that same idea for example 2 here. And it's a lot nicer because you can already kind of see what your ratio is going to be and the proportion you need to set up. So go ahead and pause the video and work through this with your group now. Okay, so it looks like that this 15 and the x are going to be corresponding, and the 16 and the 24 are corresponding. So we're going to go 24 over 16 equals 15 over x. Taking care to make sure that we have all of our numbers in the right place, and it looks like they are, we are going to cross multiply. And we get 24x equals 240. And we get that x equals 10 again. And if you remember from my little mistake earlier, 10 was there. So we did this properly. Now moving on to the last topic of similarity in polygons. In similar polygons, their side lengths have a certain ratio, and their perimeters have that exact same ratio. So the perimeter to the sides and the perimeter, sorry, not the perimeter of the sides, the scale factor of the sides and the scale factor of the perimeter are the same. So what we're going to do is we're going to use the perimeters that were given to find the missing sides here. And on the left there's triangles, and on the right there's squares. So I'm going to go through the first one. So I know that the perimeter of the little one is 9, the perimeter of the big one with the y's is 18. Okay, what that means is that I know that their scale factor will be 1/2. So I've found out what the scale factor is. That's half of what I want to know. What I now want to know is, what does each side equal? And does that match up with my scale factor? Well, these are equilateral triangles, so I know that for my perimeter of 9, it has to be split 3 ways, so that x equals 3. Same idea with my triangle with y. I know it has to be split 3 ways, so y should be 6. Now I test and I do my x over y. 3 over 6, and that equals 1/2. So I know that, yes, my x equals 3, my y equals 6, and my scale factor is 1/2. So now I want you to pause the video and work through number 2 with your group in a similar fashion. And here's example 2 worked out, so you can go ahead and pause the video, check your answer with your group. After you're done with that, the video is done.